The first step towards achieving your dreams is having the right coach. Get the best education with Embedded World and make your automotive and embedded system dreams come true. Download the app now.
Yes, and the courses also is being published in this application. That is, if you are a Android user, you can download like a embedded world, or if you are a iOS user, you can download the app called Class Plus, and you can enter this ORG code. All right, so it's not only with the courses, also for free contents also is being available. You can check it out. So in this video, the OSI defined CAN protocol is one of the very important no topic that has been discussed in most of the interviews as well as technical discussions. Also, you have to be much aware about this. All right, so how the CAN protocol has been related with the OSI layer. That is, we have the OSI layer in your engineering also. You would studied these OSI reference layers. Right? It starts with the physical layer until it ends with the application layer. And in CAN protocol holds has taken part two layers in the OSI. That is physical layer and the data link layer. So now we'll see in physical layer what are the things has been categorized, and in the data link layer what exactly the role of the OSI layer with CAN protocol. All right, so we'll start with the physical layer. So physical, the name itself you can understand, it's a physical. Physically, you can touch these things. You can touch and feel. All right, so that's what the physical layer. And the two, it's a limit. It's not like encoding, decoding, and all. It's not possible to touch, but you can consider it's a physical layer. Okay, let's see. A medium dependent interface, that is a MDI. These are connectors. What are the connectors you used to see, right? So the DB9 connector, the 9 pins will be there. That has been uh, designed as per the physical layer in the OSI. All right, so that is it's a standard. So that's what it's a connectors. Then physical medium attachments, a PMA. It's a driver receiver characteristics. That means what are the receiver, all right, or what are the drivers, that is being the pin configuration, right? So if you see, there will be some there will be the pin configuration. So it's like you'll have the diagram, your pin diagram also. So I can simply consider the pin diagram. All right, so for the pin diagram, how it should be, so how the pins like the ground or the power supply, or what are the input output. So these are all the main things will be in the pin diagram. So this pin also should be as per the OSI. In OSI physical, what are the characteristics with the physical layer holes, it should be there. All right, the first one is a connector. So connector, it you can consider this is a connector. And second is the pin diagram. Then then this is there's a pin. That's what the driver receiver characters I mentioned is a pin diagram. All right, then the physical signaling, that is a PLS. It's a bit timing synchronization and bit encoding decoding. So here bit timing synchronization is if the bit has been sent, so how the synchronization should be. It should be a hard synchronization, right? For the CAN protocol it should start with the zero. So that's what. So this has to be as per the OSI protocol. All right, so it's a synchronization and timings. So in what timings the baud rate should be there. Baud rate means it is bit rate means it is transmission of zeros and ones per second, and baud rate means transmission of zeros and ones changes per second. Okay, this is a changes and this is transmission. So let's all talk about the timings. All right, so that is what the there's a timing characteristics. Then encoding and decoding. So encoding is, say for example, if this is original data. Original data is, for example, voice is my original data. It's analog data, and it has been converted to the digital form. It's a digital form. All right, not from analog to digital form. So analog, so it is a convert to digital form. This is encoding. At the end, you are again the controller has converted into the analog form. So this is called decoding. So the encoding and decoding, encoding means it's a converting the original form into some machine understandable language. And again, when you're retrieving the original thing, that is called decoding. So that's what it's encoding and decoding. So the bit encoding and bit decoding. So these all holds the physical layer. So all right, Then coming to the data link layer, I think this is clear. So this is the first one is the connector, second one is the driver, that is the pin characteristics. Then third one is the timing characteristics and synchronizations. Synchronization is the timing. All right, so mostly synchronization and timing both are kind of the same only. Then in the data link layer, it's a physical sorry, medium access control. It's a Mac. Okay, so it's not like a MacBook, it is a medium access control. So in medium access control we have, so physical layer is, again, see, whenever you are connecting a charger to your mobile phone, or you are connecting some cables to the controller, so that physical test, that is a physical, that everything will comes in the physical, these things. All right, and once it happens, what will happen is the data starts to transmit. So that's what data link layer. So how this data link layers are responsible to acquire the physical data and put it into the controller for the data link connection. All right, that's what Mac. The first one is data encapsulation and decapsulation. Again, it's a capsule. Capsule means they put some data objects together. So that's what data encapsulation. All the data has been put into the capsule, and decapsule means again opening the things. So when you are sending, you have to capsulate everything, and at the end it will be decapsulated. It's more or less same like a encoding and decoding. All right, it will be capsuled all the data, and at the end all the data has been decapsulated. So that's what the thing. Then frame coding, that is in the frame coding, something with stuffing and destuffing. We have the bits, right? So it should be 0 0 0, then the complementary bit should be 1, then again 1 1 1, the complementary should be 0. So that's what it is, a stuffing and destuffing concepts with the CAN protocol. The error detection and signaling, in serialization, deserialization. So everything, so these are serializations are the characteristics and features of the CAN protocol. All right, so error detection, error signaling also, it's a feature. So these features being taken part in the data link layer in the OSI layer. All right, then LLC, logical link control. It is acceptance filtering, overload notifying, and recovery management. So it's a very simple. Acceptance filtering is, if say for example, if this is a, see here, this is a data link layer, and here we have the physical layer. Means you just visualize this, because in real time it will not be like this. I'm just putting as as a level. So once the physical layer is satisfied, then comes to the data link layer. In the data link layer, so what are the data can be allowed? So that is what the acceptance filtering. So the acceptance filtering plays a role to uh, to accept what are the data. So whether it's a legal data or illegal data, it will accept. So that is what the acceptance filtering. It will filters the all illegal data. Okay, illegal data with respect to the protocol. Then overload notification is, of course, if there is a more data as is in a queue, then it will give the overload notification. Then recovery management is, it talks about the errors as well as the data corrupts. That also, if some data has been corrupted, then if the data recovers, the corrected data got recovers, there also recovery management comes into picture to allow the data. So that's all about these two layer. If you have any doubts, you can leave a comment, and in the next video we'll continue with the mm, yeah, how the layers.
Namaste. Most
Okay,
people ask this question, why does God not answer my
sorry,
prayer?
someone
Does Lord Krishna
yes. Okay, so
How are the CAN layers defined?
how these layers has been defined. So that's what we'll see in the upcoming video. We'll get back to you. Bye.